Look at any major city today, and you will see a logistics network pushed to its absolute limit. Millions of packages are navigating congested, unpredictable urban grids every single day. A failed delivery attempt adds an $8 redelivery fee and $4 in support time to the initial $8 shipping cost. The risk to future revenue is even higher. Statistics show a 70% probability that a customer will never return after a poor delivery experience. For a brand with an average customer lifetime value of $200, that represents a $140 loss. I am a master black belt at Six Sigma Development Solutions, Inc., and I have seen how elite logistics firms apply statistical rigor to stop this financial drain. Despite massive investments in routing technology and fleet expansion, between 8 and 20% of all parcels still fail to reach the customer on the first attempt. This imbalance stems from the cost of quality. Most operations are weighted toward failure costs, paying for reactive appraisal, extra handling, and redelivery, which routinely outweighs their investment in proactive prevention. In Lean Six Sigma, we categorize this using the Tim Wood taxonomy of waste. A package bouncing back to the depot is a measurable defect that generates excess motion and unnecessary transportation. Without shifting the operational focus upstream to prevent these defects, companies are simply using advanced technology to fail faster at a higher price point. To resolve these systemic issues, practitioners rely on the DMAIC engine: define, measure, analyze, improve, and control. The process starts in the define phase by mapping the delivery flow using a SIPOC model. This documents suppliers, inputs, processes, outputs, and customers to isolate exactly where the breakdown occurs. Within this framework, a failed first attempt is a hard, measurable defect rather than an unavoidable anomaly caused by external factors. Organizations must establish a mathematical baseline in the measure phase before implementing new routing software or changing driver policies. This requires capturing two essential metrics: process cycle efficiency, which tracks the ratio of value-added time to lead time, and the first-time delivery success rate. Reliable data is a requirement. A measurement system analysis is used to verify that the GPS telemetry and driver logs you are relying on are accurate. Precise measurement prevents the whack-a-mole effect, where fixing a visible symptom in the warehouse accidentally creates a critical delay out on the road. Once the baseline is established, we move to the analyze phase to find the root causes hiding beneath the surface metrics. This Pareto chart analyzes over 5,000 failed deliveries. Customer not available accounts for 55%, and address unlocatable accounts for 18%. The cumulative line shows that 73% of all delivery failures stem from these two specific data points. While route density impacts fuel costs, the return on distance optimizing algorithms is capped by the quality of the handover data. If the customer isn't home or the address is illegible, the shortest path is still a failed one. In this context, logistics is a handover problem. The entire operational structure must shift toward maximizing the likelihood of a successful package transfer. The improved phase focuses on poka-yoke, or error-proofing, to stop defects before a package leaves the depot. Deploying mandatory address validation APIs at the point of customer entry acts as a digital poka-yoke. This reduces the frequency of unlocatable address defects by preventing incorrect data from entering the system. Addressing these upstream defects creates significant internal gains. Third-party logistics warehouses have used DMAIC to improve process cycle efficiency from 40% to 70%. To ensure these improvements are sustained, the control phase uses statistical process control charts to monitor driver performance and success rates over time. These methodologies are utilized by major e-commerce organizations to maintain quality at the highest possible scale. Amazon's ACES program, or Customer Excellence Services, employs blast belt-led diagnostic audits to target systemic waste in fulfillment centers. They use machine learning to process traffic and delivery density data, cutting process unpredictability to align with Six Sigma core values. DHL's First Choice program targeted the 55% customer not available defect identified in our Pareto analysis. By deploying over 3,500 automated pack stations, DHL systemically addresses the availability defect by providing customers with 24/7 self-service pickup locations. Industry leaders use DMAIC to restructure the supply chain environment, driving delivery accuracy toward a higher sigma level and minimizing the opportunity for failure. Despite the mathematical evidence, Many Lean Six Sigma logistics initiatives do not achieve their projected ROI. These failures generally trace back to 3 specific errors in how the program is implemented within the organization. The first is the leadership void. When executives treat Six Sigma as a mid-level departmental chore rather than a core business strategy, projects lack the necessary authority to overcome interdepartmental resistance. The second pitfall is inadequate training. Providing complex statistical tools to staff without proper instruction leads to flawed data analysis and solutions that do not address the actual root causes. Finally, projects fail due to poor project selection, often by taking on scopes that are too complex or disconnected from strategic business goals. When a Six Sigma project fails, the issue is rarely the methodology itself. It is the human and organizational elements that were ignored. Effective last-mile optimization requires shifting from reactive redelivery to preventative upstream data validation. The Pareto principle demonstrates that addressing just 2 variables, customer availability and address accuracy, eliminates the vast majority of waste in the delivery process. Succeeding in a high-volume e-commerce environment is a matter of building a data-driven improvement culture rather than simply expanding fleet size. In modern logistics, the most expensive defect occurs when a failure is only identified at the customer's doorstep. Formal Lean Six Sigma certification provides the advanced technical skills required to execute these improvements at an enterprise level. To apply these tools with the precision of the world's most efficient organizations, formal certification is the required path. Today, Six Sigma Development Solutions has trained over 4,000 practitioners across 52 countries to achieve these exact operational standards. Mastering these principles allows any logistics leader to build a resilient, future-proof supply chain.